So my name is Paul Sagar. I run the CAD Product Management team here at PTC. What I'm going to spend the next 20, 30 minutes talking about is what we see as the future of CAD and the emerging trends that we're seeing in the market that are forcing evolutions in the product development process. So as Chris alluded to, the physical and the digital world are converging. We're seeing this with more and more of our customers that are starting to reevaluate their businesses, their supply chain processes, to change their overall business model. Companies such as Trane, who make air conditioning units, as they're transitioning their business away from a company that sells air conditioning units to a company that is selling a service to maintain a building at a certain temperature. Now that fundamentally means they need to rethink what design means and how the design evolves and what the inputs and outputs are. More important to them now is the ability to monitor the upkeep of those air conditioning units. They want to be able to understand when they can service the product, eliminate downtime in the product. And all this leads to the fact that the product design process itself is going to change or is going to need to change to accommodate situations like this. So to help explain some of these trends that we see, I've got here kind of a familiar yin-yang symbol with the physical product or physical environment at the top and the digital representation at the bottom. Now what's important here is that there's some critical key boundary crossing technologies out there, emerging technologies out there that are helping to shape product design as we move forward. The first one is IoT, the ability to bring information from the physical world into the digital world. Now, we can maybe understand how that impacts a service department, being able to understand how a product is being used, being able to understand whether there is a product failure and whether I should send an engineer out to go and fix it. But it's also critical from a design perspective. Being able to understand how a product is designed, how a product is performing, how somebody is using your product can inform you in future design decisions that you make. The second trend that we see is around AR and VR. Now again, it's fairly easy to understand how AR and VR can help in maybe service instruction manuals, explaining to somebody how to disassemble a product. Or maybe on the manufacturing shop floor, explaining to somebody how they should go about assembling this product. But from a design standpoint, it's also critical. Being able to visualize your product full size, being able to share your ideas seamlessly with colleagues. The next boundary crossing technology is, well, it's actually two. It's additive manufacturing and simulation. Now, additive manufacturing is everywhere. Nobody in this room is obviously should be surprised by that, right? You don't seem to be able to open up an article or a magazine without there being an article about additive manufacturing and its impact on the design world. So I'm going to spend a little bit of time talking about that. The other aspect, though, is simulation. As companies are moving towards or changing their business models to more service-based models, it becomes more and more critical to understand how products are being used, optimize those products for their usage, to try and eliminate warranty issues that there might be with your products. And the final piece I'm going to talk about is what I've got here as the digital thread, but in essence that encompasses everything else to do with designing your products. So let's start out with augmented reality. Now, a recent study by Gartner says that by 2030, 80% of all machine-to-human interactions are going to leverage some form of immersive interface. So what we've done on every single seat of Creo out there is we've provided users with the ability to quickly and easily create AR experiences. Simply specify the floor that you want to put your model on and publish it. Then from using the Vuforia View free app on your phone, you can then view your design in augmented reality. Quickly, seamlessly, and it enables you to then get a good sense of your design. I design my product on this 15-inch laptop all day long. It doesn't really give me a good sense of the size, the scale of my design. But it also allows me to share it with colleagues to get their feedback, and allows me to share it in a way that my IP is protected. The end viewer never receives a copy of the data. It's always just streamed down, triangle by triangle, to his device. A lot of our users tried this out, loved it, but they wanted a bit more. So we introduced AR Design Share, an add-on capability. What that does is it allows you, or gives you, additional control over those experiences. So now you can choose who gets to see the experience, for how long, and revoke the permissions if you like. So as an example, I might have a design, I send it out to 3 suppliers, they review the design, they give me feedback, I choose one of the suppliers to move forward with, I can then turn off the ability for the other suppliers to see that design moving forward. Okay? Moving on to design for connectivity and how product design and IoT blend together. Now, another quote here, according to IDC, 70% of all discrete manufacturers are going to be offering some form of connected product. Now, that could be to the extent of a connected product in the field, but let's be honest, a lot of us here build prototypes, put prototypes in a lab, and put sensors on those prototypes in a lab to figure out how they're performing. As engineers, we design here what's on the left, the digital prototype. We know everything about the CAD model. We know everything about how it interacts. Once the CAD model is defined and our design is finalized, we go into production, we manufacture it, we ship it. And at that stage, we, in essence, hear nothing more from it. We've got no idea whether it's good, bad, indifferent. If, as a company, though, we have a strategy to instrument our products, and we put sensors on that product, and we put the equivalent sensors on our CAD model, connect the two through our ThingWorx IoT platform, that gives you the start of what we call the digital twin, a unique representation of a particular product in the field. That gives you clear insight into how that product is behaving, how that product is being used. And you can then take data streams from the product in the field and replay them in your CAD system, understanding and visualizing the real loads, the real constraints, the real boundary conditions for your design, enabling you to improve your design moving forward. So consequently, in Creo 4, we introduced capability called Creo Product Insight that does exactly that. It allows you to place sensors on your design, connect those sensors to data streams coming from ThingWorx, and replay that design inside your CAD model. But that's not the only thing it does. One thing we hear from a lot of customers when it comes to sensoring up their products is it tends to be an afterthought, and it tends to be something that is not done by design. It tends to be something that is done by the service organization. You design a product, you hand the product over to the service organization, they then go and place sensors on it. Now at that stage, the problem is the design is already locked in place. They can't make any changes to the design. And so you end up putting sensors in suboptimal locations. You also end up maybe having to choose too many sensors. But more importantly, what happens is they don't necessarily validate the data streams they're going to get from the product when it is in the field. So what happens? The product goes out into the field, starts streaming data back, and because they've never really validated what information they want to capture, they end up getting a whole host of data. Too much data for them to actually be able to do anything with. So they turn it off. It becomes useless. What Product Insight allows you to do, though, at the design phase, is not only define where you want your sensors, but also build out the data streams and validate those data streams before you build and ship your product. So moving on to additive manufacturing. Again, Gardner estimates that by 2020, 75% of all manufacturing operations worldwide are going to leverage additive manufacturing. Now, that can be as far as full final production parts, but it could also be for jigs, fixtures, tooling. The question is why, right? What is the appeal of additive manufacturing? And it really comes down to 4 key items. The first, and probably the most obvious one when you talk about additive manufacturing, is making lightweight components. Whether you're putting lattices in a design, whether you're doing topology optimization, generative design, additive manufacturing gives you the free complexity, removes the limitations of traditional manufacturing processes. The second one is flexibility. Again, with those traditional manufacturing processes removed out of the equation, you can build whatever geometry, whatever parts, whatever shape that you want. Which leads to the third one, and maybe the surprising one, which is cost savings. A lot of our customers are actually using additive manufacturing to save money. And the way they're doing that is through part consolidation. I have an assembly today of 50 components. That's 50 components I need to manufacture, or maybe 30 components I need to manufacture. And then I need 20 fasteners to go and fix all that together. And then I need to pay for somebody to go and assemble it. Okay? That cost all adds up. Or I can use additive manufacturing to go in and say, hey, these are my goals. I need to achieve these certain engineering certain engineering objectives. Let me create a single part to replace those 50 parts. Okay? And the final move in additive manufacturing or driver is materials. Every day there's almost a new material, new 3D printer coming out, whether it be polymers, composites, metals. We're seeing an explosion of different types of materials that can now be printed. And as that evolves, you're going to start and see the introduction of blended materials. And when you start talking about blended materials, then the material definition itself can be part of the design and optimization process. I want to define a bracket. Well, let me define a bracket, and the material properties of that are going to be, I don't know, titanium that blends into aluminum throughout the design. And we're putting in the specific material properties right where we need it within the design process. So that all sounds good, but the problem is to do that requires quite a lot of tools today, right? We need to be able to design the product at the top. We want to be able to optimize the product for additive manufacturing. We need to be able to validate that it meets our engineering goals. And we need to also check that it can be printed, right? Not everything can be printed. Now, the problem with this process as it stands today is it's a very disjointed process. Every step along here requires a different piece of software, a different file format. So as I go from design to optimization, I'm using a different piece of software, a different file format. Now, if there's a design change anywhere along the way, I'm right back to the beginning. Now, CAD systems for years have had dedicated capabilities in them for designing sheet metal components, designing injection molded components. But until now, they've not really had a focus on designing for additive manufacturing. So within Creo and within PTC, our strategy is to enable you to do all of that, design, optimize, validate, and print check without needing to leave Creo. From a design perspective, whether you're wanting to build 2.5D, 3D lattice structures that can be analyzed, whether you're wanting to optimize your design with topology optimization, all fully built into Creo. When it comes to topology optimization, though, there are a lot of topology optimization solutions out there on the market. What they all create, though, is tessellated data. Now, that may be all well and good. The problem is CAD systems don't really work well with tessellated data. Right? You can't leverage it in the rest of your design. And let's face it, most designs are not going to be 100% 3D printed. For a long, long time, we're going to have both worlds, traditional manufacturing and additive manufacturing, needing to work together. So I need to have a system that can work with my resulting 3D printed parts and my traditional parts. And tessellated data doesn't work well in that format. So what we have in Creo is not only do we do the topology optimization, but we also have the capability to automatically convert the results of that optimized shape back into CAD data, fully editable CAD data. So you can evolve your design moving forward and leverage it with the rest of your design components. Another aspect of additive manufacturing that is critical from a design perspective is the actual printing process, right? When I print a 3D part, I typically don't print one part at a time, right? I put them on a printer bed and I'm going to print multiple parts simultaneously. So we have the ability inside Creo to define a tray assembly, a specific assembly that understands the printer it's going to be printed on, so it understands the build volume. It allows you to place your components in. It can optimize the orientation and nesting of those components in your tray. It can validate that they can be printed. And it can also build support structures in there, support structures that are specific to the particular printer of your choice. And then the final thing is connectivity. We've got built-in connections to Stratasys printers, 3D Systems printers, materialized powered printers. These connections provide you with the ability to optimize orientations, provides you with the ability not only to connect and send the data to the printer, but also to get feedback. How long is it going to take to print? How much material am I going to need to print it? Okay? All valuable information to know and critical information to know when we're talking about additive manufacturing. So what about some general productivity improvements we've made in Creo over the last few releases? Well, we've focused a lot on improving general productivity for everyday user, making their day-to-day operations with the CAD system easier to use. Improvements in our sketching environment, improvements to standard everyday tools, extrude and revolve. But we've also added new capabilities. Back in Creo 1, we introduced the notion of what we call flexible modeling that allows you to do geometry-based direct modeling operations. You've got to do a late-stage design change to your product. I simply want to be able to pick on this face, drag it. I want to select this hole, drag it. The problem was it didn't understand the unique characteristics of sheet metal parts. It didn't understand that a sheet metal part needs to have constant wall thickness. It didn't understand what a corner relief or mitre relief is. So we've added that support in. So now you can perform those direct modeling operations for late-stage design change, geometry simplification on sheet metal parts as well. But probably the biggest change we made to overall usability was the general interaction paradigm, shifting to a geometry-based selection rather than a feature-based selection. So now I pick on my geometry directly on my model, provides you with a little context-sensitive mini toolbar that gives you direct access to editing commands, creation commands. Fully customizable, you can put whatever command you want in there. Really streamlining the process, giving the engineers, the users, access, direct access to the commands they need right at their fingertips in the graphics area where they're focusing. This also allows us to introduce full screen mode. This is something that a lot of our users have requested a long time. I'm just interested in the graphics area. Let me work there, get rid of all my menus, it's cluttering the screen. So we introduced that. Now obviously not every command would be available in that mini toolbar. So if you need access to other commands, simply move your cursor up to the top, the ribbon pops down, you get access to those commands as well. Model-based enterprise, I'll skip that one. So more and more companies today are realizing that they need to change from a 2D-centric design process to a 3D-centric process. They're suffering from too many problems with misinterpretation of 2D drawings or missing information on a 2D drawing that takes an exorbitant amount of time for them to fix, resolve, and in a lot of cases it's too late by the time they find the problem. And so consequently, we've spent a lot of time working on closing some gaps we had with certain ASME ISO drawing standards, but also re-architecting our GD&T underpinnings. Our GD&T is now semantic, intelligent architecture, so it understands what the annotation relates to. It understands the tolerances, how they relate to other geometry in your design. Working with our partner at Sigmetrics, we also introduced what we call GD&T Advisor. That's capability that will guide you through the process of adding GD&T to your model. It will educate you in the right choice of GD&T for the geometry that you're picking. But also, more importantly, it will validate not only that your design conforms to the appropriate standard, but also validate that your geometry is 100% constrained, okay? Eliminating any downstream risk of missing information leading to misinterpretation of the design. Now, back in our LiveWorks conference in June of this year, LiveWorks is our annual conference that we have at PTC. We announced an exciting partnership between PTC and ANSYS. Now, PTC has been a leader in CAD for 30 plus years. ANSYS has been the leader in engineering simulation for nearly 50 years out there. This partnership is going to enable us to bring out, in essence, the best and broadest set of design through simulation capabilities on the market today. The gold standard, if you like, for simulation, leading to simulation-driven design. Now, you're probably, hopefully, all familiar with this kind of traditional approach of product design, right? You start with concepts, you do some detailed design, you get a certain way down the design process, you start and do some simulation, you go into prototyping, you go into manufacturing. Now, for a long, long time, the industry has been trying to leverage simulation within the design process, and they're leveraging it for significant reasons, right? We all want to improve quality of products. We all want to get to market faster. We all want to better understand how the design is going to perform in an environment. And simulation provides all those capabilities. But the fundamental problem is where simulation is sitting there, right? It's sitting after you've done a certain amount of design work. And so if you run your simulation, you then find the design isn't optimal or the design isn't going to work. So you need to go back and make changes. The problem is you're making changes at the expensive part of the design process, where it's fairly detailed out. So a lot of engineers maybe don't necessarily use it as effectively as they could. And if they do use it, they're using it for a final validation exercise versus more of a simulation-driven design approach. And a lot of the reason for that is simulation software today is pretty complicated, right? Doesn't matter what software you use, it can be pretty daunting to use. And a lot of engineers feel they don't have the confidence to use it, or they need to reach out to a specialist or an analyst to go and perform that task. Secondly, I've got my design, it's a fairly detailed design, I want to now go and simulate it. Well, to simulate it, the first thing you have to do is really take a copy of it and simplify it down. Because if you try and analyze it in its detailed phase, it's going to take an eternity. So the trade-off with simulation is always about how can I reduce enough information off my design to be able to simulate it with still realistic, accurate results, but in a time frame that is manageable and effective, right? Now, we all know design is iterative, right? We don't just reach the point of final design and analyze and go straight into production. There's always a feedback loop there. Now, the problem is in this process, if every time I make a design change, I've got to go back, I've got to make a new copy, I've got to simplify it, I've got to rerun the analysis, that could take 2 hours each time. It's extending that whole development process. That's not something that we think it should be like. We think it should look more like this, where simulation is so easy to use. Simulation is so fast. Simulation allows for continuous iteration of the design process, that it almost becomes invisible that it is happening. And thanks to the breakthrough technology that ANSYS has and the partnership between ANSYS and PTC, we're able to put this capability on every seat of Creo out there today. In the first quarter of next year, we're going to be introducing what we call Creo Simulation Live. We're going to be introducing a beta of it at the end of this year. But in essence, what it's going to do is within the modeling environment of Creo, it's going to allow you to quickly and easily define, these are my constraints, this is where my geometry is fixed, this is the loads and where the loads are applied, these are the materials, and then instantly see the result, right? You're not waiting 2 hours, you're not having to go through and refine how you go about meshing the design. It does it for you straight away, and you're seeing it instantly. And because it's in the design environment, I can now go and make changes to my design. I haven't got to go to a different system. I haven't got to go and make the changes, rerun the simulation. Every time I make a change, I make an edit, I add new geometry. It's always analyzing the results, whether it's structural, thermal, modal analysis. What this really means is engineers are going to be able to try out many, many, many more iterations of the design, defining and getting to the optimal design as possible, right? Simply by the fact that they can more rapidly iterate upon the design, get the feedback on the design change instantly. Imagine this as nothing more than just a display mode, right? I want to view my model in wireframe. No, I want to view my model shaded. No, I want to view my model with the simulation results on it. It's that quick. So it's happening real time for every user. But our partnership with ANSYS is going beyond that as well. So this allows you to do the rapid iterations. Get to a point in your design that you're 99% confident that this design is what is going to work. You've evolved as many different iterations and design scenarios as you can. But you're still probably going to want to do a final high-fidelity simulation. And so for that, we'll be introducing the ANSYS high-end solvers directly inside Creo. So for the final validation stage, you're going to be able to take all those loads, all those constraints, all the boundary conditions you applied in Simulation Live, and run a full-fledged, high-end simulation to validate your final design results before you go into production. Okay? So hopefully that's given you a good overview of the trends we see in the market today, where we're investing from a CAD perspective for additive manufacturing, for design for connectivity, and also to enable this game changer that we believe and we see happening to lead to simulation-driven design. Thank you very much.